Let me start with a bit of a contrast, two different ways of thinking about the world and understanding how it works. In the first, you're an architect. You come up with a plan, a design, you think of a structure and the ways in which the pieces interact, how each part relates to each other part, how they kind of work together, or how they might stress against each other in some way or another, right? And then you go out to see whether this design actually matches the world. In other words, you test to see if the concept you've come up with is something that works in the real world in some way, and you test that to see the degree to which that conception matches with what you observe out there. If it does, then your architecture of the world holds. If it doesn't, then you go back to the drawing board. You maybe switch a few things. You look at the parts and see if maybe you missed a piece, right? And so this is one way of going about understanding the world. It's more or less how we conduct scientific inquiry. It's the method that was developed mostly in the what we call the natural sciences now, biology and physics, and it seemed to work there, and so it was adapted into the social sciences in many ways. We begin with a theory, we derive some set of hypotheses, and we go out and test them against observations in the world. Now let's think about a second way of thinking about the world, in which you arrive at a ruin and the structure is partially collapsed. Perhaps it's old, perhaps pieces are missing, perhaps it's from different eras. Some parts have been altered over time, either through wear or through someone going in and moving things around. You don't know what the original design was. You have fragments, you have pieces, stones, traces, patterns, debris that could be random or could be man-made. Your task then is to reconstruct what has happened, to come up with a reasonable explanation for the way it maybe was or is, and what you can kind of piece together from the evidence you can get that's out there, the traces that you have left over. You're no longer working from a plan. You're working backwards from the evidence that you've collected. You are, in this conception, something not of an architect, but an archaeologist, right? You're engaged in an archaeology, a social archaeology, or maybe a better way to describe that is something of a forensic investigator. These two modes of inquiry, architectural versus archaeological, coexist in the sciences, and they always have. But they put different demands on the researcher, not so much in terms necessarily of the methodology, which is often shared between the two in pretty important ways, but in the epistemology, in the way that we understand the world around us. And so in the architectural mode, the one that I think is more traditional in the social sciences, at least the ones that I've been exposed to, there's a certain privileging of clarity, of abstraction, and of this ability to generalize your research, right? The kind of golden standard, although this has largely been abandoned in the kind of post-positivist world that we live in, is this, the same thing that we used to go after in physics as well, which is this grand unifying theory, right? A theory of society that would allow us to understand, predict, and explain how society works. So that's that idea of a general model of social interaction is kind of the, if not explicit, at least the implicit aim of a lot of these efforts in the traditional scientific architectural model of science. But I think increasingly, we talked about this at the very beginning as well, whether this was the end of science. I don't think it's the end of science, but I do think that some of the more interesting work that is done, especially around trace data and big data, looks less like architecture and more like archaeology. Less like kind of testing a blueprint and more like following clues towards a reconstruction of the crime, I guess, or the situ, or the social milieu, right? We're trying to reconstruct it from the traces of observations we can actually make. And so I think I pointed one of you earlier in the semester towards a book I like for this, but a lot of what we're doing is sort of is detective work now, rather than the kind of traditional view of what we see as science. Now, this distinction between the scientist and the forensic detective is not new. It's also not a clear dichotomy, right? Many of the foundations of modern science really emerged from what we would now call or recognize as kind of forensic practices or forensic sciences. Consider the autopsy. I mean, early autopsies were not conducted to test some kind of hypothesis about the way the body works. I mean, that's not quite true. Some of them were. I'm sure you know the history of kind of body snatching and paying for cadavers, so that early scientists in this architectural context could test their ideas and think about mapping and charting what bodies look like and how they were organized. But largely they were done to figure out why someone died, a very specific kind of urgent question. Why did they die? Was their death natural? Was it the result of violence? Was it the result of neglect? Was it an outcome of a particular disease, right? So they're trying to figure out a pretty straightforward question, which was, why is this person dead? And in the case of a potential homicide, was it what was the source of that death? How did that occur? And this is a very practical kind of question. And it came up often with practical, we're talking about epistemology here, so it came up with kind of practical knowledge. Anyone who's watched any police procedural at this point knows that, there's petechial hemorrhaging. That's a pretty good indicator that the person was strangled. We have a homicide. This sort of, that's almost a cliche at this point for kind of television police procedurals. So, you might come up with some kind of generalizable patterns that you could recognize in other contexts, but overall, you started to kind of accrete this knowledge, right? So you'd start to look for patterns of different kinds of evidence that might point to different kinds of causes. You might start to classify different kinds of disease structures and how they affected different organs. And as you had more and more physicians doing more and more autopsies, you started to see more of these patterns, and you'd start to get mappings of organs, the beginnings of sort of, what would be a science of anatomy and pathology, right? From this generalized knowledge emerged that wasn't just specific to finding out a very specific question, but rather was a model for how the human body worked. In other words, this architecture grew out of the archaeology of these particular case-based autopsies. And that kind of traces over to a bunch of other kinds of things that forensic science has done. This includes things like fingerprints, right? Fingerprinting started as a way of identifying individuals for both in an administrative context as it is today, administrative context, but also in criminal context, trying to track people down. So if you wanted to try to figure out who the criminals were, and whether it was the same criminal that was doing something one after another, the discovery of various ways of printing the body, of biometrics, but particularly this surprise that there seemed to be very little, that fingerprints seemed to be very distinctive to the individual, really started to connect this idea between individual identification and data. I mean, it was the very first databases were around this. There are some interesting detours here around phrenology and other things in terms of trying to predict crime and other bits here. But you did have this kind of connection of collecting large amounts of data and then using that to try to answer particular questions, not just solving crimes, but also placing people at different places at different times and tracking on institutional location of people as well for an administrative task. So it's the same kind of thing. It's trying to understand patterns at a large scale. In this case, the logic of trying to find things that can be useful to answering particular kinds of questions. I mean, we've already been talking a bit about trace data, and this is an example. It's hard to think of a better exemplar of trace data than the fingerprint, or than a lot of different kinds of traces that you can find at a crime scene, for example. So these basic forensic practical methods end up becoming the basis for a broader, generalizable scientific reasoning. Move that up to now. Digital forensics is an emerging field, often out of cybersecurity, but now really standing on its own, used both in criminal investigations, but also largely in civil investigations. We've seen this in large-scale dumps of data, that both in criminal and civil cases, where you're trying to make sense of what happened based on a very large number of digital traces, logs, metadata, residual kinds of pieces of media left over in computational systems. And it means trying to piece together all of these fragments into, you're getting pieces of a larger picture, but you can't get the whole picture. So you get pieces of it, and then you're trying to fill in, infer what's in the middle of these. The different kind of inference and the kind of inference we see in more architectural systems where you're trying for generalizability. The idea of generalizability is, I've observed this in multiple cases, is it a general rule, right? In this case, we're using inference to say, we have this evidence. Can we infer some of the evidence we don't have and think about the connections that might be there, right? Something similar happens for data journalists, especially, but also journalists who are using observations. I mean, the standard process of journalism, but also kind of, especially as we've moved into data journalism, we have people that are looking at the same kinds of things. They're getting at all of these little pieces and seeing whether they can pull a story out of it. It's a question of forensic reconstruction, right? Of building up a structure based on what you've observed. Again, rather than saying, I have a thought of how this might work, let's test it against the evidence. That would make for a really interesting, but probably very ineffective police detective, right? Someone who goes into the crime with a theory about how all crimes happen and then tests it against a particular case. It just wouldn't be as effective as how criminal investigations usually occur. Same is true for journalists. If you're trying to show something at the outset, you're kind of poisoning your instrument to start with. And that's part of the problem, is this priming issue. But also, it's probably not effective in leading you to the source that you're trying to, or the story that you're trying to uncover as a journalist. I guess the other piece of this might be a question of, as we look at kind of digital journalism, especially, and some of these large scale digital forensics, things like tracing networks of criminal organizations, that leaks into an area that's often called open source intelligence, or OSINT, which used to be a little corner of the intelligence. Most of the intelligence that people might be using were captured signals, like captured telephones or telegraphs or radio communications, and you could use some of that, or information that you'd gathered from human informants, right? Someone going out in the field and earning someone's trust and getting information from them. That tended to be the vast majority of the information that someone working in the intelligence field might use, or I guess to assert, especially from the 1950s onward, things like remote sensing of various kinds. So flying jets or other planes over places and taking photographs and trying to deal with that sense data, or increasingly satellite data, and trying to make sense of what's happening from those images. That was like the majority of what you used. Now, they always used in the intelligence community open sources. So they always looked at, you always got all of the major newspapers from your target nation delivered, and you were always looking through those newspapers and trying to, catch out little pieces of data that might be useful to you. But that piece, the open source piece, has become much larger as so much of our lives are now lived online. So, a lot of the stuff that you would have needed to instrument in some way or get human intelligence on in some way, people now give up on their own by having apps in their pocket. And so open source intelligence has become a huge part of the intelligence venture overall. And that dovetails again with the way that some people are doing criminal investigations, especially at a large scale. And that dovetails again with many of the methods that social scientists are now using to try to picture the world around them. So this is a bit of a blur. It's not purely theory driven. It's not purely descriptive. It's reconstructive. We're seeing a borrowing, not just kind of a borrowing of techniques from forensics into the social sciences, although there's certainly some of that. It's a reemergence of a mode of inquiry that's always been there. This kind of overlap between accreting practical observations, applied research, and having that build up into larger models of kinds of a rule of thumb that then becomes a pattern, that then becomes sort of a general understanding of how things work. So that's kind of one side of it, but that's building towards theory rather than kind of this traditional theory, test, revise that we've seen in the sciences in the past. We're not asking so much, what should we expect? We're asking, hey, what happened here? And I think that's a worthwhile question to be asking. Now, as I suggested, I think there's a couple of different models of inference that are being applied here. You're inferring stuff in both cases. Maybe, again, we'll come back to that adducing stuff, making that jump, that leap in two different ways. Both have the same kind of problem. They're both trying to infer something from incomplete data, right? And sometimes indirect observation, and sometimes imperfect observation, right? The data is both imperfect, indirect, and incomplete. Those can be our three I's. And because of that, we have to infer a larger picture, or try to jump from that to something that's a bigger picture, or a different picture, I guess. You never have all the data. You never observe the system in its entirety, and you're always working with some kind of traces, right? But how these two, I don't want to call them traditions, but these two approaches to understanding the world handle this problem of incompleteness is different. In traditional social science, the goal is to move towards generalization, to make some very clear observations, and then say we can make with some level of confidence, we can say that this is true no matter what. If you have a survey and you have some answers, the idea is that the answers you have on this survey would apply pretty much anywhere else. We're trying to make that inference. You're trying to we've talked about model building. You're trying to talk about not just building a picture of what's happened in this particular situation, but a model that can apply in a variety of different cases. The statistical methods you use are usually trying to estimate relationships between variables, and those estimations of how those variables are related should, again, apply not just in the situation you're currently investigating, but in any similar set of cases, right? So that's kind of what you're trying to do in the social sciences. The individual case in this context matters far less than the overall pattern, right? Forensics is the opposite side of this, right? Forensics seeks to really get some level of coherence within a single case. You're trying to take limited information about this single case and say, can we come up with a narrative? Can we come up with an overall picture that better represents the entirety of it? So, you may not be able to, in the case of someone who, doesn't have an alibi, or you might not be able to know their inner thoughts, but you can take some evidence around that and say that it infers their motivations, for example. And so you're asking whether this particular configuration of evidence is best explained as one story or as another story. This is kind of the essential thing in kind of especially criminal forms of forensics, right? And so that's a different kind of thing. We don't really care about whether, the evidence I collect in this particular case is not going to apply to the next case down the road, not directly at least. We might find some patterns that cross over. We might find some rules of thumb, but that's not really, we're not looking for that kind of generalizability. The inference we're making here is from the data that we have to the larger scenario, larger picture, the larger case, as I noted. So this is that abductive leap to the best explanation for what you're observing in this particular case. And so this is kind of where the tension is between the two approaches, right? In a theory-driven model, you largely ignore the data that doesn't fit within your model. This is how we have these large paradigm shifts. As long as your overall statistical inference holds, then you've said something important that can be held in other cases, right? In a forensic model, you're really trying to any piece of evidence that doesn't fit is especially important, right? Because it can topple your entire inference to the large picture. So it is a difference, right? Anomalies are not. In the case of generalizable social sciences, what do we do with an anomaly? Some of you have just done this in an exercise. You trim it off, right? It's something that we should ignore because it's going to mess with our model. In the case of a criminal investigation, that's a clue. It means that whatever your narrative, whatever your conception of the case is, if you've got something that sticks out in a weird way, you better figure out a way to explain that anomaly, because otherwise it can upset the entire apple cart, right? So it's a different way of approaching how we have how we could relate what we do know to what we don't know is kind of the short way to say it. There's another big difference here between the kind of forensic approach and social scientific approach, and that is the role of time or urgency, I guess. Traditional social science operates on a timeline that's largely set by the researcher, and that's not quite true. So yes, I design a study, I collect the data, I analyze it, I then present it at a conference usually, and then I publish it in a journal. This could happen over a period of years. It's not entirely bounded by me, but it's also bounded by whether I can get funding, whether I need to get tenure. There's some institutional pieces here, whether I've gotten it cleared by IRB. All of that is kind of bundled, and it's got a life cycle. It's rarely as cleanly as I've just delineated it, but generally you do have kind of a beginning and an end, and after you've published it, then you move on to the next study. That's a very bounded kind of space in which you're engaged in this. And, research can get old, but, there is a shelf life for some kinds of research. Someone might beat you to the punch on something interesting, but generally speaking, you're not on a clock, right? You get it done, you work through it. It's good if you can do it quicker, but it's not essential, right? To the work itself. Forensic investigations rarely have that luxury, right? They're often conducted under certain conditions of urgency. Some of that may be a question of kind of, again, the institutional piece, right? That you can only hold that person for 24 hours or whatever, right? Some of it is that the evidence itself will degrade, especially if you're going out and collecting people's eyewitness accounts or something like that, or physical evidence as well. You might only have certain access to certain spaces over certain periods. And so new information may emerge in the time in which you're doing the investigation. This is this kind of, again, if anomalies arise during the period of investigation for a social science piece of research, you do have to address that. But often it's by saying, okay, we have to recollect the data, or we have to cut off at the point where whatever the anomaly occurred was, something happens in the news that changes the data collection process, for example. Usually you just have to kind of then, either take the early data or recollect the data or do something to get around this. But in the case of a forensic investigation, especially in the criminal case, when new data emerges, that might, again, shift everything right away. And so you might have to then quickly go and find other information. So you have this evolutionary process when you're engaged in forensic investigations that you don't have in social science more generally. I mean, I guess we've been talking about kind of criminal sorts of things, but this is also true in terms of large scale monitoring. So if you're monitoring, for example, for cybersecurity, and you see a new vector of attack, that's something that's an ongoing sort of a thing. And what you will have to think about, like, are you seeing the same vector in different places? Has the approach taken changed slightly? Do you have a new version of an attack that you've previously countered? How do you walk in and do you announce this broadly first, or do you come up with some kind of a mitigation approach first? These kinds of questions are something that emerges very quickly over time. And, people die if even in the case of certainly in the case if you're tracking a murder, I guess, but also in the case of a cyber attack. If you can't counter a large scale cyber attack, people are going to die in many cases. If someone goes and holds a hospital ransom for their data, that could lead to people's deaths. And so you kind of have a different kind of a clock on you when you're engaged in this, and you have a different kind of pattern by which the data comes in. When you're collecting it as a social scientist, you have a period of data collection, and then that ends, and then you do the analysis. And that's not true for when you're engaged in forensic work. Often you're collecting and analyzing at the same time. You've come up with a picture, you see some holes, you might try to collect a little more data in a different way here, or you might have to revisit the analysis of something you've collected in terms of evidence here. And so it's more of an ongoing process when you're engaged in more forensic kinds of approaches. I mean, another example of this is not just kind of attacks in terms of cybersecurity, but tracking a disinformation campaign, for example, during an election, right? The data is not static. It's being generated continuously, and the system you're studying is changing as you observe it. So there isn't kind of a stable model of how this affects one another. It's an ongoing kind of mush that you kind of have to try to make sense of as you're running up on it. So it requires a different methodological posture. You have to have a set of tools quickly available to you and ready to deploy. You're not just analyzing a system, you're monitoring it over time. You're building, you've seen this in a number of universities. They have now sort of social data observatories, things where you're kind of looking at you're looking and collecting data anticipatorily, I think that's a word, in anticipation of something that you might want to study. You may be collecting data at a large scale without really knowing what question you're trying to answer ahead of time, right? So this kind of ongoing monitoring of the environment is part of it, this kind of ongoing, and the ability to then focus on and analyze pieces on the fly as quickly as you can, and having those tools at the ready and being able to kind of change them in such a way that they can then be analyzed very quickly, or be analyzed on an ongoing basis, not just collected in an archive, but also analyzed on an ongoing basis. And so, on the one hand, a research study is designed to test a model and decide whether or not your hypothesis, whether it is explained as a hypothesis or not, whether it's assumed as a hypothesis or a model, is valid. Whereas an observatory is really about, isn't designed to answer a single question. It's designed to continuously sort of collect and organize and interpret and often visualize information over time, kind of at a continuous rate. This is what astronomers do with the sky, right? They look for anomalies. A social science observatory would do something similar. It would look for anomalies. It would try to detect interesting cases that you could then dig into more deeply. You could have things like platform observatories. We don't really see this in the same level, but there's certainly things like media monitoring observatories where you can kind of trace, this actually comes out of the open source world, where a number of companies started systems that were a lot of the early continuous translation systems were taking, for example, everything broadcast in China from various news sources and continuously translating them and looking for doing anomaly detection to see if something would come up that might be of interest, that might show something that we weren't expecting. This is what observatories that are designed for detecting pandemics and disease vectors do as well. They kind of try to get data from a large number of places, and as soon as you see an anomaly, you say, okay, there's something going on here. Is that something we need to look at more closely? So that kind of use of ongoing analysis of dashboards, of visualization, wasn't traditionally part of what social scientists did. They might kind of be brought in to inform that process, but it wasn't part of our kind of mainstay of a process. But more and more, I think we're getting kind of an overlap. It's not just a tool, it's kind of an infrastructure for ongoing inquiry. And I think that these days we are seeing a shift from the traditional hypothesis-driven research in terms of the way we theorize towards this kind of ongoing observational approach. This idea of looking for emerging patterns and then trying to say, okay, what does this tell us about society or about a particular case? I think that's a lot more of what we do these days. So what does it mean to be a social science detective, right? How do we take this shift seriously? And then how do we prepare for it as emerging social scientists? If we move away from the primary goal of social science, of producing generalizable theory, and towards the idea that it is aiming to understand complex evolving systems in context, what does that mean for us? What do we have to do? And I think we start to see the emergence of new roles that are not kind of the traditional social researcher. This idea of a social scientist as a detective or as an analyst or as the scholar as a data journalist of a sort, these are kind of I think an emerging set of ways in which people may not describe themselves, but I think we could look at some, especially over the last decade or two, some emerging scholars who really fit into those contexts better than they do the traditional scientist. So what does that mean? What do these scholars look like? Well, they might look like, as I said, a data journalist, someone who uses computational methods to uncover stories hidden in large data sets or interesting cases that they can then tease out and create a narrative around. They don't usually begin with a hypothesis. They're on a beat, right? They're looking for information within a particular area of news and events. And so if they have a suspicion about something, they might try to, that might be something like a hypothesis, but generally speaking, they're looking for something to emerge out of their observation, something that's that's a thread that they can pull on, right? And so that's one model for how we might engage in social science. Open source investigators, people who are doing intelligence analysis, for example, might reconstruct events from publicly available data, creating a detailed analysis that can have some immediate real world implication, some application, for example, to policy or to, a tactical stance, for example. Policy analysts, to go to the policy side, are looking at real-time analysis. Traditionally, obviously, they're probably looking at polls, right? They're looking at public opinion, but also they're probably looking at, this was one of my roles was as not a policy analyst, but was as an economic analyst, right? So I'm using a whole set of data to kind of say, what's our trajectory, both in terms of what do we need, where are we going to need to apply our resources, and are we going to have the resources to apply, right? This is an ongoing, I was doing this on a 2-week turnaround. I think if I were doing this today, it would be more like on a 2-day turnaround, just because we can do more with the data than when I was working with it. But policy analysts have to think about how the facts on the ground are affecting their policy choices and being able to respond with that. These are kind of applied research roles, and I think there's a lot more of those than there are traditional kind of scholarly research roles at this point. So this is a methods course. Does this suggest changes in what methods we should be approaching and how we should be approaching methods? And I think mostly this is a matter of sort of an epistemic stance or an axiological stance, kind of how we're approaching the reason we do what we do and the way we think about the world, and not so much the tools that we use. Many of the tools, like I said, I think that we can benefit from borrowing from tools from cybersecurity folks and from those who are working on, in open source intelligence and a bunch of other areas. I think there are tools that can kind of cross over very neatly. But there is kind of in between this, in the meso level, there is a bit of a shift that we might have, which is, this traditional hypothetico-deductive model emphasizes predefined variables, controlled comparisons, statistical testing. And I've already said, I think that if you look at research for the last 40 or 50 years in the social sciences, you'll see just a huge number of inferential, a lot of survey work, and a lot of it aiming to infer to a general audience, to a general population. And that kind of inferential statistics has been the key tool to that. And I think we've already seen that on the down. I think if you looked at the mention of p-values in social science literature over the last 40 years, you just see it, hit a nosedive in the last 10 or 15 years, where people are not as concerned with samples that might generalize to a much larger population, for example. So some of these are clearly going to shift. But in a more nuanced way, I think the forensic approach really emphasizes flexibility, iteration, synthesis across multiple sources. We would usually call that kind of a multi-methods approach. I think you also see less and less of a mention of a multi-methods approach in papers because it's expected at this point. If you're only using a single method, there are areas, I think probably in psychology, you still see a lot of, straightforward theory, hypothesis, experiment, outcome, try to generalize it. I think you see a little bit more of that. But there is this evolution towards, I just found this. Now I'm going to have to use a different method to approach kind of extracting the data I need to, again, fill in the edges of this picture, figure out more about what's really going on in this space. And that's less about, do I have this one tool? How am I going to hammer this into such a way that I can make a case for this giving me an answer about a variable? It's more about, let's see what tools I have to try to figure out, to try to extract observations from the situation I'm trying to understand, and then use different analytical approaches to fill in that picture, to infer the pieces that I can't see. So you're not looking at single studies, you're looking at kind of an ongoing evidentiary record, right? That messes with a lot of the cycles of what we do in the social sciences, but it does work much more within the applied world. And when I was a graduate student, I was kind of trying to keep, even when I was doing my doctoral program, I didn't know whether I would end up kind of in the professor's role. This is, I don't want to go too much into inside baseball here, but, academia is very much like similar markets, like the NBA and like drug dealing. You've got a very large number of people at the bottom end, and then the pyramid narrows at each stage, and you've invested a lot along the way. So, there's a whole bunch of people who go out for a PhD, and of those, about half in the social sciences usually make it through. I think it's somewhere between a third and a half. And of those, a tiny, tiny number go into any kind of higher education. And of those, a minuscule number get into a research one institution, a research heavy institution. And of those, not all of them tenure. And then you're 20 years into a process of starting a career that then gets left behind if you don't tenure. So it's a weird climb. And as a result, if you are going on to a PhD, I would recommend you do this as well. I certainly did have a plan A and a plan B, and the plan B in reserve was that if I had a route to academia, I might go there. But I definitely wanted to make sure I was able to work in other contexts as well. And as a result, I was doing a lot of work in I was in Seattle, so with technology and in finance and in a bunch of different places in consulting. And that continued to be a part of what I did after I actually did end up in the academy, as I continued to consult for throughout to a lesser or greater degree, depending on the year, throughout my academic career. I've also been consulting. And so I've always had this A and B. And so for me, the B, I don't know which one's the A and which one's the B, but the applied piece has been really important to the way I think about methods in the more academic setting too. So I recognize that the tools that I've learned to use on the scholarly side can be very effective in especially thinking about and analyzing very applied kinds of problems. But the other way is true as well. And so this idea of building up evidence towards a question and using trace data and using qualitative observations and engaging in network analysis and archival approaches and computational methods and just throwing them all at a problem so that you can start to uncover all the pieces that might give you that bigger picture. That's a big piece of what I would do in an applied situation. And because of that, I think it has become a bigger part of what I do on the academic side as well. I follow leads. I triangulate. I do on the fly, very quickly pulled together research that luckily at ASU we have an IRB that can respond to that when it's not public data, and so that's helpful. But I mean, I try to be nimble in terms of my approach to this. I revise my model on an ongoing basis as I get more data in, and I follow more threads. This sounds like it sounds like it's messy, and it totally is, but it is also not an abandonment of rigor. I think quite the opposite is true, that because you're being flexible and following the evidence instead of trying to find evidence that supports your current model, I think that it can be more rigorous than the more traditional model. Of course, it still requires kind of careful documentation and note taking, maybe even more so than a traditional model, because you may be changing gears midway, and you need to have that documented in some way. So I've drummed on this the whole time, this idea of keeping a research notebook and keeping track of how you've changed things along the way. Part of that is because I think that more of you will be doing this kind of work where you may kind of say, whoop, I've just found something that invalidates my model. I'm going to shift the way I'm approaching this problem. And that's, I think that's kind of like the fly in the ointment in the case of a traditional research plan. And I think it is a required part of doing interesting work today. So it requires that you be a little bit more transparent about your uncertainty, about the kinds of inferences you're making, about ways of telling the story of your inferences, about the kind of data you're using and how confident you are about the picture or predictions that you're making. And it requires a fluency in how those narratives and those models are related to data. But it is not more or less rigorous because of that. It requires a degree of humility, of not selling something that you don't have. And it requires you to engage in ethics in a way that is much harder than in a traditional research environment, where you have very clearly bounded research edges, where you're less likely to step into something quickly, where you're less likely to become a player in the system that you're observing. It requires actually a much more thoroughgoing and ongoing reflection on how you're engaging in research. And so that is a new challenge as well.